Thank you very much, Enrico. Hello. You are sitting at home.
Hello, everyone.
In Italy.
Thanks for inviting me. It's a great opportunity. Thank you, Marcus. It's been an interesting initial session, so it's good to be here. And let me stress once again what Brian told at the beginning of this meeting. We are living very peculiar times nowadays, and we all realize how important the job we're doing, because this infrastructure, the data center cooling, is essential to the operation of data centers, and this is becoming really an important infrastructure. And without that, we wouldn't have this webinar. And in Italy during the lockdown, we couldn't work or go to school. So let me switch off my camera and go directly to.
You can leave your camera on. I have a feedback that it's the people have very good structure.
Excellent.
So
excellent.
You can keep on.
I just wanted to avoid. So once again, let me introduce myself. My name is Enrico Boscaro, and I'm marketing manager for HVAC Industrial, and I work for Carel Industries. We actually make components, so controls and other type of components used to manufacture air conditioners and crack units. So somehow I would like to thank Jamshad for making the perfect introduction to my presentation. So he was able to give you an overview of all the different technologies used for the data center cooling. Now we are trying to deep dive on some of those technologies that might help achieve the efficiency in data center cooling. So this is the agenda. We will have three main topics. One is high efficiency cooling through DC technology for compressors. Then a focus on humidification, and in the end, I'll talk a little bit about the integration of all the different technologies. As a matter of fact, even if we are manufacturing components, whereas Airedale, for example, they are building units, I think we all feel part of this ecosystem, as someone defined it, and the entire industry should work to improve the efficiency of the system, as this industry is growing, and potentially after these tragic events of these days, infrastructures which are already being deployed around the world will be even improved to guarantee even better digital services. So let's have a look at different technologies to improve the data center cooling. Data centers now, as we are heading towards hybrid IT on the IT side, it seems, as we've seen in the previous presentation, that we are going towards a, let's say, hybrid cooling technologies. So data centers very often now consist of a complex system, maybe with an area where you can have traditional crack units, but also add-on of air handlers for direct or indirect free cooling. Then you could improve condensers, you could improve the crack themselves, or even separate and have high density areas with different technologies. Still, though, I would like to focus on one technology. So we've seen chilled water, direct free cooling or indirect free cooling is becoming very, very popular all around the world. But I believe that still for the area, especially if the edge architecture will grow, we won't see direct expansion disappear. That's why maybe it's the case to have a look at how we could possibly improve the efficiency of the X systems. So we see that happening around the world. VLDC technology for cracks and for BLDC, I mean brushless DC motor compressors are becoming increasingly popular in certain areas of the world. In Asia, for example, they are really, really popular. These kind of compressors have been used for VRV, VRF systems since many years. And recently I noticed that there are countries in the Middle East area, like Kuwait, for example, that they would like to have for domestic air conditioning only units with inverter compressors on. So why are those becoming so popular? When we're talking about DC compressors and inverter compressors, we mean brushless motor compressors. So you need an inverter to run this kind of compressors. They are very, very efficient motors, and on top of that, they are also capable of a wide range of modulation. But here are 5 reasons why this DC technology is becoming really, really popular for data center cooling all around the world. So first reason is because this technology is used now since many years for fan motors. And so the energy saving you can achieve with this kind of motors is well known. Sorry, I need to go back one slide. So it's well known, and there is a great potential for compressors. Second reason is that they can modulate. As it was introduced in the previous presentation, now with a cold aisle and a hot aisle containment, it's becoming paramount to have the possibility to control the supply air temperature. So if it is quite difficult to control with an on-off compressor, with a modulating one, it is possible to achieve a better control and a better stability of supply air temperature. Third reason, this control of temperature is combined also to a reduced inertia of newer systems. So with newer type of units like in-rack units or even totally contained units like this one that might be the somehow I have I'm clicking somewhere, sorry. With the units with a reduced air volume, so not large room conditioning, but rack-based air conditioning, a reduced inertia might require even more capability of modulation, and especially a wide range. These technologies can allow you to have a minimum speed of 15%, so better fitting also a variable load, something that is going to happen more and more. Another reason why this technology is becoming important, so high efficiency, supply temperature control, low inertia systems, But on top of that, they could be combined with free cooling technologies. Depending on the area where you are standing, there is the possibility very often to have direct or water-based free cooling to take advantage of favorable conditions. Typically, and we've seen the graph before, there is an area during the year, so a specific period during which outdoor air temperature is low enough to run in free cooling mode. Very often there is a threshold that will trigger free cooling mode compared to compressor-based mode. Normally, because an off compressor, they cannot modulate. So as a consequence, you need to select between free cooling mode and compressor-based mode. Now, with the modulating compressor, it is possible to take advantage of partial free cooling, so extending the running hours with the free cooling mode, because the compressor, being capable of modulating, will give only the missing percentage. So it can be a version with a damper directly, or an additional coil, like the dual coil with an external heat exchanger with water, even using spray water. We know that water consumption combined with energy consumption is an issue too. Finally, another good reason why this technology is becoming very, very interesting is because it's changing the concept of redundancy. Normally, see, this is a very typical layout of a data center. In this example, we have 3 units running and 1 in standby. So to have 300%, these normally might result in an uneven air distribution, and then you need to create complicated logics to rotate these units, so that when one unit fails due to any kind of issue on that unit, in this example we have an N+1 configuration, the standby unit turns on. Whereas if you have modulating units, you could design the system to have all the units operating or more units operating at partial load. At partial load, one of the characteristics of these compressors is that they are very, very efficient. So it's better to run them at partial load, have all the units running. This will result in a better air distribution, because you see you have 4 units, imagine they are in the corner, and only when one unit has a problem, all the other one can accelerate to obtain 100% and have a backup of the cooling power needed for that. All right. So these are reasons why this technology is becoming really popular for data center cooling for DX systems. Obviously, it's not only one component, one technology that will allow to create a real energy efficient system. As the energy consumption is growing, as these systems are becoming more complex, we need to try and optimize the energy saving of the entire system, starting from the components, what we do, to the entire management of the system itself. So another opportunity to obtain energy saving is humidification. We've seen in the previous presentation how the new thermal guideline by ASHRAE and the Technical Committee 9.9, they are giving a wider range of temperature and humidity for data center. So the first thing would be try and designing systems with higher temperatures and a wider allowance of humidity. Nevertheless, we still should have a minimum control of humidity due to the potential risk of ESD, electrostatic discharge. This is a big debate. In certain areas of the world, they are trying to get completely rid of the humidifiers, and we can understand the reason. Let me show you an example. This is a legacy data center. It's a bank, so with a typical low temperature design, room-based air conditioning, 25–40% on the return, 17 degrees on the supply. These type of systems are out there a lot. So new design systems, they can take advantage of higher temperatures. But there are still a lot of data centers that might benefit of some retrofit, for example, to improve their efficiency. In this particular data center, and this is a bank once again, there was a total cooling load of 1.2 approximately megawatt, and there were 135 humidifiers using electrode humidifiers, our humidifiers, by the way. And these technology, as we've seen in the slide before, they're using approximately 750 watts to have the water boiling and create 1 kilogram per hour of steam. But it's not only the energy, the concern in this type of system. So if you see the cooling power here, more or less was using as installed power 400 kilowatts. In the same system, 25% of that power, and 20% of the total power was used for humidification. So there is a great potential, and this is the other message. Very often we talk about new data centers, but high efficiency is not applied only to new data centers. We should have a global perspective when discussing about energy saving, and the growth that we foresee for the future is not made only by mega data centers, but there will be a growth also for co-location and edge. And this could result even in retrofit and improvement of existing data centers where new servers will be installed. And this opportunity of using a different technology, so removing humidifiers and finding a different way for control the humidity, might be a great advantage, not only for saving the energy used by the humidifiers, but also the power. You see here, in this case, 20% of power, of installed power, could be removed and be used for other purposes. This is one of the reasons why very often we see that happening around the world. So if you have the possibility to use an adiabatic technology, which is basically using water spraying, or other ways to put air in contact with water, if you are able to achieve this humidification, the air humidification happens using the energy of the air itself. So you have an effect. The adiabatic effect is something that I'm sure you all know. If you are able to achieve this, you could humidify at the same time, reduce temperature, but on top of that, you're not going to use a lot of energy. One technology, talking about technologies, that is becoming very popular, is ultrasonic humidification. Very often adiabatic technologies are room-based, for example, in this case, using an open area. Ultrasonic technology is basically using piezoelectric transducers and it's using the high frequency vibration to create small droplets of air, then collected by fans. Those fans are driving those small droplets of water, and these are almost instantly absorbed by the air, thus increasing its humidity without using a lot of energy. Why room-based? Because it's adiabatic. Room-based, or sometimes small air handlers, so in ducts or other areas, it's not very easy to put them into crack units due to airspeed and space. Space is essential for this type of units. But for example, in this case, imagine you have hot aisle containment and room. The fact that these kind of units can modulate, they create 1 micron droplet of water, and using very low power, so less than 10% of power consumption, compared to isothermal humidifiers that have to boil water. They can work for a very long time. This type of humidifier should include water treatment to avoid having any type of mineral and dust in the data center. These nebulizers in the end can properly modulate the amount of humidity, and they use a small content of energy. So very often this is something that has been used around the world as an energy saving retrofit for data centers. So removing electrode humidifiers and size an adiabatic one only for that purpose. This is saving energy and, as we said, reducing the installed power. As I said before, these are 2 examples. So DC technology for compressors and adiabatic humidifiers. These are 2 technologies that might help reduce the energy consumption of both existing and new data centers. On top of that, as it was mentioned before, obtaining energy saving for the data center air conditioning requires some level of integration of all these different technologies. So as a matter of fact, we see that now we have more and more hybrid cooling, different technologies, even for existing data centers. So existing crack units combined with air handlers for free cooling, direct and indirect type, but also different areas with the different temperatures or UPS or battery areas cooling. They might use different technologies. And as we are using different technologies, there is a need of coordination of all these different technologies. So very often, and this is what is popular, it might be a legitimate question. Shall we have all these components then being directed by the BMS, by the DCIM? Probably, and definitely this is what also was said before, each unit should be optimized, whereas there are a lot of opportunities if the unit controller can be integrated. Nowadays it's very, very popular to use protocols to integrate the controllers and to let them work together to achieve a lower PUE. So it's important to measure, use the communication between all the different devices and possibly optimize them. Very often, though it's not a simple integration, it's not a simple data visualization, but it requires some specific HVAC skills to obtain this result. So in the end, that's why very often units, crack units, this is very popular. They have a controller and they have a communication among all of them to perform the lead lag and redundancy management. So for synergy and backup. On top of that, then I would say always there's a BMS or a DCIM to look after all the different components and verify the status of all of them. That's why probably there is room now with newer technologies, so Ethernet-based multi-protocols or multi-connection, multi-serial lines to define a level that we might call integration and service. So a communication between different technologies like air handlers and cracks to optimize the cooling part with the specific skills. Often this level, so optimizing different technologies, it's important to have efficiency at the component level, at the unit level, and then in the end at the system level. This might be also a link between the big DCIM and so the system, the centralized BMS could obtain information from this integration and service. So the level of integration of the different HVAC units without monitoring directly every single point, every single data point. What is this level doing? It's data collection, data presentation, measuring PUEs, and showing PUE is already a first level of integration to understand what we are doing, sharing with other system, and adding some logic, as we said before. Jamshad made a great example, changing the water temperature depending on water opening. Okay, and this can be a controller, a display, or a more sophisticated system to show all the data and integrate the cooling and energy part, which are the two essential infrastructure. So monitor, control, and possibly optimize. All right, and give an easy access to all the different components. Let me go to conclusions as we are approaching the end of the presentation. So data centers are rapidly growing, and as well their energy consumption is growing. Several technologies are available now that might help achieve energy saving, and we should consider all of them in an ecosystem perspective to perform the best saving. Switching to high efficiency components as a benefit not only for the energy consumption and the green awareness that we all have, but also on the return of investment for example, retrofit applications. We know that this situation might lead the entire world not only to sanitary crisis, but also an economic crisis. So cash flow might be a problem in the near future. So retrofit might represent a strong market driver to improve the efficiency of existing data centers. Integrated system will be fundamental, paramount to guarantee the efficiency. It's not only one component, it's one component included in a unit and then in an entire system. Using then flexibility, compatibility, and adaptability. So these are key aspects to find the right solution. We don't believe there is one right solution for the all the data centers. It's the entire industry will have to cooperate to find the right solution for the right data center. And that's it.
Thank you, Enrico.